For those of you that have your text, we're looking at section 1.4.
Do we have to bring our textbook?
No, you don't bring your textbook. I mean, you won't have anything to look at besides what I do here, but it's probably not an idea because then you can see in your book what I'm talking about. These videos, I'm trying to work with the IT department to get these videos up, so hopefully it works out. They're fairly large in size, but I have a terabyte on my my OneDrive, so Blackboard, YouTube, I'm going to try everything I can, yes. No, and the reason for that is because of liability. If it gets stolen, you're financially liable for it, and then you don't want to have, I don't want to have a tension between the teacher and the student. Oh, why'd you let someone take it? Well, it's not my responsibility, yes.
The only reason why I asked that is because I don't have enough time.
Not even during lunch? Or after school or before school?
No, not my book, it's in the locker, but I don't have enough time.
If you guys come in like while I'm taking attendance because you swung by your locker to grab your book, I'm fine with that. The biggest pet peeve I have is like trying to go to the bathroom in the middle of class. You know what I mean? That's the thing. That's the thing. You're coming in a little bit late in the beginning. That I don't have an issue with as much as the interruptions in the middle of class. That's what I'm saying. If you come in a little bit late because you had to get your book, obviously don't be ridiculously tardy, but enough to where I knew you had to take some time to get your book and then come over here. That's fine. Yes.
So we have to bring the book every day.
You don't have to bring your textbook. You don't have to bring it, but it's recommended if you want to see inside the textbook to see what you're looking at, what we're talking about. But no, you don't have to, because especially you even have to have one at home per se, because at home, like I said, if you Google the name of this textbook, the first link comes up, Pearson. It's got a digital copy of this textbook. Okay, I'm gonna try to be as clear as I can with my notes too, so you guys can refer to page numbers and what I'm talking about. So day 5, we were supposed to go into complex numbers and quadratic equations. We're going to go into that now. Complex numbers are actually fairly straightforward. So let's talk about this. So this is Monday, August 29th, period 2, advanced topics. And we're looking at sections 1.4. 1.4 and complex numbers. Is the 29th. You guys have reviewed, you guys have touched on complex numbers from like algebra 2 before. So we have complex numbers are in the form, actually leave it on here, a plus bi. And we're not going to go anything more complex than this, where it's just a plus bi. Okay, so let's review some. We're going to be looking at addition, subtraction, multiplication, and multiplication of complex numbers. Let's review some what I means. Anyone remember what I is? The imaginary unit, and it stands for we say let I be equal to the square root of -1. So let's definitely go over the powers of I. Now I is actually pretty straightforward because it starts to repeat. So if we say, okay, I is I, we'll leave it written as I. We'll never write it like the square root of -1. We just leave it as I. But understand that this is, or saying this is what I is. It's the square root of -1. I'm not going to get into too much of the theory. I might show you guys a video maybe later this week if we have time about imaginary numbers, or which is this imaginary unit I. But they do exist, and without them, we could not complete the algebraic system would not be a closed system. So they absolutely do exist. They are absolutely important, especially in the world of electrical engineering, as just one example, besides the world of math. So I equals I squared, what would that equal? If I is the square root of -1, I squared would be, no, -1. Imagine you square something that undoes the square root, leaving you -1. I cubed, so the principle still stays the same. I cubed is like if you did I squared times I. So -1 times I, if you want to simplify it right there. So -1 times I would just be -I. Right? I'm going to go ahead and pull this guy up a little bit. No. Oh, no, not this game. All right, so I don't know why it does this. If I just want to select this, and it wants to sometimes grab the whole thing. I don't know why it does that. All right, so let's do that. Go back to here. So then finally, I to the 4th power, sorry, I cram it here. I is I squared is -1, I cubed is -I. So I to the 4th should be the same if you did I cubed times I, or if you did I squared, right? Because I cubed times I, you would add the exponents, you get I to the 4th. Or I squared would also give you I to the 4th. Raise your hand if you don't understand what I'm talking about, how I get that, because that's important. Okay, so when I'm saying I squared, what do we do when we raise an exponent to another exponent? We simply just multiply the exponent. So this would be, I squared would be I to the 4th. Or you could do I cubed times I, which would also be I to the 4th. Okay. This is just to help you figure out what I to the 4th is. Once you have it memorized, you'll never have to go through this process again. So what would I to the 4th be, regardless of which way you approach it? You can say, look at this guy, which is -1, and square it, or you can take -I times I, but it's a lot easier just to square -1 to give us just 1. Okay, I'm gonna erase this here. So let's continue here. Now this is where the pattern repeats. This is why I don't think dealing with just I and adding or subtracting or multiplying complex numbers, it's not that difficult, because the pattern repeats. What would I to the 5th be? I to the 5th should be I times I to the 4th, which is just going to be I times 1 is I. Yes? I to the 6th, -1. So this is where you see the pattern repeats. I to the 7th, -I, and I to the 8th, 1. And so the pattern goes on forever and ever and ever. So every 4th power we have repeating going on here. So as a quick example, anyone need more time? No. As a quick example, if you have something like, if I asked you on a test or a quiz, I to the 57th power, okay? Let's keep it simple. We know that I to the 4th is 1, okay? So any power of I that is a multiple of 4 is going to give us 1. Even I to the 0 would give us 1. So what is the largest multiple of 4 that is less than or equal to 56 or 57, maybe it said. You have a calculator too, you quickly, okay, 56 divided by 4, is 56 multiple of 4? I believe it is. So this should be, so far so good. I to the 57 should be equal to I to the 56 times I. Just basic principles of multiplying the same base, you add the exponents. I to the 56 should be I to the 4th raised to what power? Say 9? 9 times 4 is 36, but I think it's 14. You guys, I don't know if I've actually listened at once. Yeah, 14. Yeah. So I to the 4th to the 14th is I to the 56, and we still have the times I. Now, why is this convenient? Because I to the 4th is 1, so you have 1 to the 14th power times I. So therefore, I to the 57th is just equal to I. This is just an example. Does not make sense. Anyone else doesn't make sense for it? Just so okay. Do you guys understand the principle that when you multiply numbers of the same base, you add the exponents? I mean, technically there's a 1. I don't have to write the first power. It's understood to be a 1 here. 56 plus 1 is 57. Okay. Why did I do that? The reason I did that, because I know every 4th power of I is 1. I to the 4th is 1. I to the 8th is 1. I to the 12th is 1. I to the 16th is 1. I to the 20th is 1. So I purposely broke this up so that I could write base I to some multiple of 4 times I to whatever else I would need to make up 57. Why did I do that? Because I can write this as I to the 4th to some power, because 1 to any power, 1 to any power is just going to give us 1. That's why I did this. So I to the 4th, you guys know the rule when you have an exponent raised to an exponent? That's multiplication, so this is this. I to the 4th to the 14th is I to the 56th. And so 1 to the 14th is just 1. So 1 times I is just I. So I to the 57th simplifies to just I. Because the pattern repeats. It repeats over and over and over again. Does it make sense now? Sort of, kind of. It's just all it is based on the principle that because I know this, I'm going to break this guy up so that I can write this as a 4th power to whatever power. Because 1 to the 14th is just 1 times 1 times 1, 14 times, which is just 1. Okay, so let's look at adding and multiplying complex numbers. So if I just give you some example, let's look at page 135 for those of you that do have your text. Let's look at, say, number 2. So number 2 on page 135. We have -2 plus 6i plus 4 minus I. You guys ever worked on something like this before? Some of you have, some of you know. Okay. So basically the principle is we're going to get down to something that fits this form. You have what is your real number plus your imaginary number makes a complex number. All numbers are complex numbers. Even the number 2 could technically be written as 2 plus 0i. Okay, so let's go ahead and do this. When there's a plus, we can pretty much ignore the parentheses. It's not necessary to associate these two. I can go ahead and start combining like terms. You treat this in the sense that you think about like a variable. You know, an I is a letter, so I can only combine like terms. So, all right, so do I have my real values? I have -2 that look like obviously real values. -2 plus 4 that are not in terms of I. What's -2 plus 4? It's just 2. So let me actually do it in more than one step. So we have -2 plus 4, and then I'm going to associate these two together, plus 6i plus -I. -2 plus 4 is 2, and 6i plus -I is 5i. That's nothing crazy, nothing complicated here. Just you added the real parts, adding the imaginary parts, and that's as simplified as it gets. That's it. 2 plus 5i. That's number 2. Okay, let's move on to something that looks like multiplication. So something like, what's ridiculous? Oh, how tired you are, yeah. It's Monday. It's Monday. Let's look at, yeah, talk yourself into it. I hear you. 12. We have -4 minus 8i times 3 plus I. Okay, so this should look very familiar, right? Foiling, boom, 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 and boom. Okay, so -4 times 3, -12, -4 times I, -4i, -8i times 3, -24i, and -8i times I, -8i squared. This is just an expression, and we're just going to simplify it. So combine like terms. Go ahead. Yeah, so these -4i minus 24i, those can be combined. So we have -12 minus 28i. Now this minus 8, what is I squared? -1. And then going from here, we have -12 and the +8 would combine to make -4. So we'd be left with -4 minus 28i. Questions? How did I get -4? I got -4 because -8 times -1 is +8, so I just combine -12 plus 8 to get -4. Good question. Okay, so I showed you addition of complex numbers, multiplication of complex numbers. Let's see, division.
Yeah, division.
Number 22. Still on page 135. Three over 4 plus I.
So the 2, 12, and 22, they're all on page 135?
Yes, this is all page 135. In fact, page 135. If I cannot upload these videos, which I hope I can, I will definitely at least upload these flip charts but they're definitely small enough. Okay. 3 over 4 plus I. You don't want to imagine trying to actually divide 3 by 4 plus I in the sense that, you want to try to do this. This is what we don't want to do. Okay, what do I do? So what you want to do is you want to multiply the top and the bottom by what's called the conjugate. Okay? All the conjugate is this guy, except I just changed the sign to 4 minus I. Okay, again, from a terminology, we're going to refer to this is called the conjugate. Don't know why it's called the conjugate, but that's what it's called. I should have done this in blue because I've already started doing the problem. I'm going to try to keep the original problem in black. It's unaltered. Okay, so doing this, watch what happens. So we have the top, which I'm going to leave as for right now like this. So I really want to focus on what happens at the bottom. And now be careful, right? It's the whole binomial times that whole binomial. 4 times 4, 16, 4 times negative I times 4, positive 4I, and then I times negative I. Do not simplify the i's in one step. Leave it as I squared, I cubed, I to the 4th, I whatever power, and then simplify. You just avoid, so you can avoid making a simple mistake. Okay, and then from here, I'm going to work to the right, which is nothing. I don't prefer to do that. I like to work down, but because of the slide, I'm going to work to the right. We have 3 times 4 minus I, and we can expand this guy later. One good thing to keep in mind, by the way, when you're doing math is leaving things in factored form until the very end, because sometimes you'll find out when you leave it in factored form, that can be an advantage for you because you can end up simplifying things up in the top and the bottom of a fraction. So I will expand this guy at the very end if I have to. So multiplying by the conjugate, look what this does here. It gets rid of these I terms, right? And let's not forget, you're allowed to multiply the top and the bottom of a fraction by whatever value you want besides 0. You'll have an equivalent fraction. That's all this principle is here. I'm essentially multiplying by 1, technically, right? 4 minus I over 4 minus I is just 1. So it's going to be the same exact expression. It's going to look different, but it's going to be considered in proper form. So here we have 16 minus 0 minus I squared. Well, what is I squared? Negative 1. So this now becomes, I need to shoot over to another slide, so I won't do that. I will shrink this. This becomes 3 times 4 minus I all over 16 minus negative 1. Just be careful when you do this. The I squared is negative 1, so it's 16 minus negative 1. And then now working over here, I have 3 times 4 minus I all over 17. This is properly written. And I'm fine if you guys leave it like this, but obviously you can go ahead and expand this if you want to. 12 minus 3I over 17. But I would give full credit for this here. You can leave it at the top in factor form, that's fine. So do understand that 3 over 4 plus I is the exact same value as 12 minus 3I over 17. Okay, so when they say do division, don't think of it as actually doing the classical idea of division that you guys think of, like doing actually long division like I first showed you. This is the way you don't want to do it. Think of it as I need to rewrite this so that it's in proper form. And proper form is there's no I term in the denominator. Okay? That's 22. The next section is when it's not written in I, but it's the same idea. It's just being careful with basically notation. So any example from the next section would be fine. Let's just do number 30. And back. Same page. This is still page 135. Square root of negative 81 minus the square root of negative 144. What would this simplify to?
9i.
9i. Thank you. Very good. 9i. Anyone not see that? I'll show the step in between.
So you square it and then get rid of the negative by
Putting the
putting the I.
Yeah. So let me show this so you can see it. This principle here is just like this. If I did. Remember, you're allowed to break up radicals as a product into separate radicals. This is the exact same thing as this. And you say, oh, okay, well, square root of -1, that's I, and square root of 81 is 9. So that would be 9i. That's what's going on here. So 9i, and then this guy here minus, what is this? 12i, yep. 9i minus 12i, I know, math in the morning is tough. Negative 3i. Practice plus, because this is advanced topics. We'll go on to the next section. Same page. That's 54. I'm not going to give you guys like the application exercise, the ones that are like the really tough problems, the word problems. I think I'll probably have those as bonus questions. So if you ever want to attempt something like in the application exercises on page 135, where it says application exercises, you can definitely try those. I might make one of those a bonus question. Okay. So 54 x squared plus 11 over 3 minus x. It says the directions are to evaluate this for x equals 4i. Would anyone like to, someone being distracting? Would anyone like to try this? From the class? Take a shot at it? No? Okay. All right, so I'm just going to substitute. Wherever I see x, I'm going to substitute 4i. So we're going to have, I'm going to knock this down a notch. We're going to have, 4i, now that whole value squared, plus 11 over 3 minus 4i. What would the top become? What is 4i squared? Careful, careful. Think. It's 4i squared. So if you have to do it in the long way, it's 4i times 4i. 4 times 4? 16. I times I? I times I?
Negative.
Let's leave it as I squared for now. And then we'll simplify the next step. Plus 11 all over 3 minus 4i. You guys can still see that in the back? Still clear enough? Okay. So from here, I squared is -1, so we have 16 times -1 plus 11 all over 3 minus 4i, which is just simply going to be -16 plus 11, which is -5 over 3 minus 4i. And then you guys know from here that you cannot, what I emphasized in the last one, you cannot have I terms in the denominator. So, does anyone remember when we multiply the conjugate, good, which is what? Stop in your way. 3 plus 4i, right? Just changing the sign in the middle. And you'll know it works because you'll get something that doesn't have I in the bottom after you do it. So 3 times 3, and by the way, just be careful, make sure you're foiling. 3 times 3 is 9 plus 12i minus 12i. Okay, the O and the I of the FOIL go away, leaving you minus 16i squared.
What? Before we close.
I'm not showing the fact that the middle are going to go away. 3 times 3 is 9. 3 times 4i is 12i. Negative 4i times 3 is negative 12i. So the 12i and the negative 12i, they go away. That's the whole idea of the conjugate, by the way. It eliminates those two middle guys of the O and I of FOIL. And then the last negative I times 4i is negative 16i squared. Is that okay if I leave that? I'm verbally stating that the 12i and the negative 12i, they go away. And then here, again, you can leave it in factored form. And then what does this become? 9 minus 16i squared, the saddest 2 I've ever seen in my life. 9 minus 16i squared. 9 plus 16, right? Because I squared is -1, so 9 minus 16 times -1, so 9 plus 16, 25. And negative 15 minus 20i over 25. Excuse me. Yes. Well, this is an imaginary number. It's connected with that I. So no, that's as simplified as I gotta get. Negative 15 minus 20i is negative 15 minus 20i. There's nothing you can do. But there is something that I even told you guys to make you have to watch out for. The whole reason we leave it in factored form. Yes, go ahead.
Can you divide top and bottom by 5?
That's exactly what I was getting at. I noticed that, like, wait a second. I said to leave it in factored form for a good reason. Because if we leave it in factored form, -5 times 3 plus 4i, -5 and 25 can both be divided by -5, leaving you divide by, sorry, I'll divide by 5. So I have, that become a -1, this will become a 5, right, just simplifying fractions. So the most simplified would be -3 minus 4i all over 5. This would be the most simplified. Yeah, that'd be a good idea. I'll give you. So that's a good question. I would definitely give you a significant amount of credit if you get to where I showed. But like I said, leave it in factored form, and then you can see, oh, okay, I can simplify this some more, and then this, because this is those simplified right away. So just try to leave things in factored form. We like factoring in math because it shows us things that can be simplified. Okay? Going to try to touch on some quadratic equations. Or quadratics. Solving quadratics by factoring, which I think would be a review for you guys, for those of you that are coming from Algebra 2. So this is section 1.5. Quadratic equations. Let's just look at one problem and then I'll assign you some homework. Not a lot of homework, but not about that. Page 137. X squared minus 7x plus 10 equals 0. I'm not going to go right now. We have a few minutes. So I'm not going to go into the AC method. I'm not going to show it very clearly right now because remember when this is a 1, then it's pretty straightforward to just look at this guy, right? How many of you have not done this before? Just factoring quadratics? You guys definitely should. I'd be concerned otherwise. It's a huge element of Algebra 2 that we do a lot of, right? We know it's x and x. Now, when it's a 1 here, then again, all you have to focus on what factors of 10, when added together, give me negative 7. Negative 5 and negative 2. I said I would switch over to colors, so I kind of put a little fib there. We'll correct that. So there, the given is in black. And again, I always have done probably thousands of these. I still check though. X squared minus 2x minus 5. Okay, that's negative 7x. Negative 5 and negative 2 is positive 10, so I know I factored it correctly. So what would the solutions to this equation be? 5 and 2. And I don't even need to check for extraneous solutions. They're not going to exist because this is a polynomial, it's a quadratic. There's no issue of an even root of a negative. There's no issue of division by 0, right? So I don't want you to check. I mean, okay, you could check them and you better make the statement true to make sure your solutions are correct. I should say that, but we're not going to have an issue of any restrictions on the x. If I plug in 5, 25 minus 35 plus 10, that makes it true. If I plug in 2, 4 minus 14 plus 10 also makes it true. So they both are correct. If you have time to check the work, go ahead and do so. And we'll get more. We're going to do nothing but quadratics over Tuesday and Wednesday. So for your homework for tonight, which I'll give you 2 days to do homework. It'll make it due Wednesday. I want you guys to do on page 135. I'm going to write this down. 3, 7, 9, 17, and one more. Not a lot. You need 2 days to do 5 problems. But make sure you understand them. I'm not going to collect homework in any of my classes. I talked to Mr. Hutchinson. The way I'm going to do it, Wednesday, you pull out your homework. I'm going to go by and I'm either going to give you credit, half credit, partial credit, some sort of partial credit, but you're going to show me that all the problems are at least attempted. I want to see if these problems are attempted. I don't want to see any blanks. Okay, I want to see you try to figure something out. Yes.
What's the name of the book?
The name of the book is in your syllabus. If you need a copy of the syllabus, let me know. I'll get you a copy. But the name is Blitzer, Algebra and Trigonometry, 4th edition.
Okay.
If you Google that, you will have. I don't want to hear. I couldn't find the book online. It's the first link. It's the first link. There's still maybe some books. Sure. That works. 379 1727.
Thank you.
Mm-hmm.